Yeah, hello, welcome everybody. I'm happy to have you in this webinar. I'm excited about another opportunity to talk about linked data and SKOS and how those things fit together. And yeah, let's roll. Just a few words about myself. My name is Andreas Blumauer from the Semantic Web Company here in Vienna. And yeah, I'm also the product owner of the PoolParty semantic suite, and I've been working in the fields of text mining, semantic web, and linked data for a couple of years now. And yeah, the agenda looks as following. I would like to start with a short intro about knowledge graphs and linked data, followed up by various perspectives on the simple knowledge organization system. And when the question comes up, okay, how would those two things fit together nicely? I'd like to come up with some thoughts on a linked database information architecture. And after that, I'm proud to present the latest release of PoolParty. And embedded in all those topics, there are several live demos. And I'd also like to invite you just to put into the chat or into the question field whenever you have some questions. Just put some of them into this field, and we are happy to discuss that at the end of the session together with you. And usually we also open up the microphones at the end. So if you want to stay for a couple of more minutes, we can talk to each other in person. Also, we can do a deep dive into the latest release of PoolParty at the end of the session. I might show also some snippets of a live demo here. Yeah, so just to get things started, just keep in mind those 3 steps. I wish that I can bring over that message to you. That's, I would say, our overall approach. Start simple as it is with taxonomies or thesauri. Enrich these graphs with linked data, with external information, with your own databases, of course. Make use of custom schemas, of ontologies, and then align those knowledge graphs with additional data from your enterprises. And of course, also bring in your document repositories. So that's the whole idea. It looks simple. Of course, it isn't. It's a technical issue, and most of all, an organizational issue. And those 2 levels I'd like to discuss with you in the next 45 minutes, about 45 to 50 minutes. Just a few words about the company behind PoolParty and the company I'm working for. We've been on the market since 2001. Started at that time already with the ideas to bring in semantic technologies to several industries and companies. Of course, at that time, the semantic web of W3C was not really mature enough due to a lack of standards and so on and so forth. So it took a while until we brought our product to market, which was in 2009. And from that on, we were able to develop a large number of projects together with our clients, of course, also the product and the standards and the underlying technologies. Most of all the databases, the graph databases, developed further and further. And we are now in a very interesting position, I would say, because we can see a tremendous shift on the database market towards graph database oriented technologies. And that's the very interesting part of the whole story. So it took a while, but now in 2014, I think we're finally there, that yeah, large customers, large enterprises, large organizations are really interested in the semantic web now. We also have some partners on 2 continents, in the US and also in Europe. There are system integrators, there are taxonomy specialists, there are linked data specialist. So if there is any consultant in our audience or any company would be interested in become a partner, just contact us. We are very open to discuss that. And as you can see, there are many industries interested in linked data and SKOS-based thesauri. So it starts, of course, with publishing industry. There is manufacturing, there's retailing, there is energy, and also public administration. Okay, so that's just to warm up a little bit. Let's go into the first round. What about knowledge graphs and linked data? What is it all about? Interestingly, the really big ones, they've all their graph-oriented technologies already in place. Most popular one, I would say, is Google's knowledge graph. I will come back to this topic very soon. And just recently, also Microsoft introduced its Office graph, which is now being rolled out on different places. And you can see, I mean, interestingly, the images are pretty similar to each other, aren't they? And yeah, and it seems like the way of thinking, the way of engineering knowledge and data in general has changed a little bit over time. So why is that? So let's dive deeper on this topic. One sentence I'm very interested in is it's all about things, not strings. I think that's the key to smart data. It's the way it's more similar to the ways we as human beings also think about the world. We don't have documents or tables in our brains and on our minds. It's about things. It's about entities which are being connected and related to each other. And the way we started back in the 70s, 80s to engineer our data is a bit different, of course. Of course, that has something to do with the, let's say, available hardware at that time, but now we are in the position to be able to process graph-oriented data, and that's the next step, I think, of managing information all over the places. So why is Google's knowledge graph just about to transform search? So that's something you probably have tried out in recent months. If you type in, let's say, if you look after a person, a place, an organization, whatsoever, you not only get the traditional documents, but also the fact box around this entity. And that's the basis actually to ask complex queries. We could also call them questions, as we as human beings are usually doing. We don't talk to each other by strings. We ask for entities. We want to have answers to our questions. Somehow we forgot that, I believe, after all that years of document search on the web. We want to have integrated views on things, so it's good to have context information around. All entities are somehow in a network. You can use this fact box to traverse the graph. You can jump to the next entities and look up, for instance, the parents of Tim Berners-Lee, what was their profession, and so on and so forth. And of course, this fact box is something very interesting. I would say also for the publishing industry, you can bring in here your own information. You could be inserted dynamically. For instance, if it's about a place, you could deliver into this fact box the weather information and so on. And now just think about what would be if your company had already such a knowledge graph, which is the backbone of this. You could really ask questions in your you can ask questions to your search engine. Actually, it's not a search engine anymore, it's more an information engine. So you can try that out with Google. When you type in who are the parents of Tim Berners-Lee, you will receive that as a result. So we already close to that. But the problem here is, of course, it works very well with, let's say, publicly available knowledge. But in most companies, most organizations, they don't have even a appropriate full text search. That's the problem. So they are really years and years behind this status of having an information engine in place about the domain-specific knowledge. And in the next few minutes, I want to show you how the road looks like toward such an information engine. How does it work? So if you look at this fact box, Tim Berners-Lee, who is a computer scientist, there's a definition. There are several facts around this entity. When was he born? What's his nationality, and so on. It's all stored as a graph. So if you look at this gray box up here, that's the representation of Tim Berners-Lee internally. And it has attached several labels, also could be also synonyms and things like that. It is connected with another entity, which is London, and this one again is connected with another one, with a tourist attraction in that case, with the London Eye. So that's just a really small snippet of a knowledge graph used by Google. So the question also is, why should I use graphs instead of relational databases? I mean, that's the most obvious question always at that point. And Google is using Freebase. That's the basis as its knowledge graph. And it was a project formerly run by a company which was acquired later by Google. And if you want to just work on this single data silo, then probably a relational database is good. But what if you want to be linked with other such knowledge bases, like DBpedia? For instance, in DBpedia, Tim Berners-Lee has again its own entity, but you can put in the state or the fact that those two Tim Berners-Lees are the same thing, or the same person or entity actually. And then maybe in this database you have other specific knowledge about entities. Just think of certain domains like the pharma industry. Several companies, they do a lot of research on several aspects of a protein. Others do something else. What if they work together? And that's the fact. I mean, the pharma industry is well known for its collaborative efforts. And again, you have others like geonames and so on and so forth. So you can, when you start using graph databases instead of relational databases, it's much easier to scale up, to get linked to other data sources. So for instance, geonames can offer to you geographical information like longitude, latitude, and things like that. And then again, of course, you can ask, why should I use semantic web standards to model my graphs? Could be any format, isn't it, a proprietary? But the reason why semantic web standards are probably a good idea is because they're already based on URIs and HTTP. And you can reuse a lot of standards-based vocabularies which are already out there. And then following a collaborative effort, you can create links, and so on and so forth. So that's the result of the first couple of years of the semantic web. That was back in 2011. And this network of information just exploded. And the interesting thing is that it was just an additional layer on top of the document web. The semantic web is not only about entities, it can also link entities to documents. And I believe that's the main issue here, because documents, of course, are still, if you think about all the publishers, they all have document-oriented views on information still. Although there's also kind of a trend towards a more graph-based information management. But again, you have to link those two worlds. That's clear. And if you put it on top of standards which are provided by W3C, then you can build very, very powerful standards-based query and answering machines. And I don't talk only about natural language input like Wolfram Alpha or the question I just gave as an example with Google. It's also an extension of this, let's say, typically autocomplete and faceted search we all know more or less already. It goes beyond this typical search paradigms. It's more about building smart information engines which can answer complex queries and questions. That's the whole idea, I believe. And therefore, you have to link information from a lot of types, from different silos. Okay, short pit stop. Linked data is a data model based on graphs, and it can represent and process a wide range of information. Linked data is really powerful. It's very flexible to be used to describe all the sources we typically have in our enterprises. And it's also very suitable for publishing industry. Dynamic semantic publishing is the term coined at the moment. And it's all about using information in distributed environments. So I believe that's one of the most famous sayings about the semantic web. It's not the semantic which is new about the semantic web, it's the web. And I believe that's very true. So that's a pretty famous example in the linked data world. The BBC is one of the largest media companies which already use linked data a lot. So for instance here, if you have a country profile, there are many data sources and content management systems which have information about Burkina Faso in that example. And of course you would like to have them in one place. From a client's perspective, it doesn't make sense to click around. You just want to have it as a dossier, as a profile. Same thing here. That's an energy profile of a certain country. I show you this as a live example. So that's a system which is based on linked data, and here about 10 different databases were put together or dynamically put together. It's done automatically in the background, and it's about energy profiles of certain countries, like let's say China, or you can search here. Let's go to, I don't know, Germany. And here on this, in this little box, data is derived from DBpedia, and then there is an event database, and then there is a policy database run by an organization called REAP, and then there are key statistics derived from the World Bank or Eurostat and so on and so forth. And those data are in different databases, and there are APIs, there are different formats, and they're all put together into one linked data warehouse, which is based on OpenLink software's Virtuoso. And what you can see here is a SPARQL query in general. We'll talk about SPARQL a bit later. Okay, I'm going back to the presentation. And I come to the second topic. So we had a short intro to linked data, and now I want to put various perspectives on SKOS. SKOS is a standard which is part of linked data, and it's simple, as the S is standing for. It's a simple knowledge organization system, and the question when it came out for many people was, SKOS, isn't that too simple? We need ontologies. That was one perspective, and then others were coming from a different perspective, said, aha, that's a new standard to describe taxonomies and thesauri. We haven't used such a standard before. We used other standards for taxonomies for many years. How can we adopt that? And things like that. So the main question is, why should I use SKOS? And I think, again, it's about accessibility. You can access SKOS very simply. They have all the concepts, the blue circles here have a URI. You just make an HTTP call and you get the information, either machine readable if it's a software agent, or maybe as a visualization for human beings. And the whole standard is you can educate people in about 1 hour and they will understand. And that's very important if you think about the first years of the semantic web. A lot of ontology managers were around and were explaining how the semantic web should look like, and there were not many people who embraced the semantic web at that time. It was a hard time for us at the very beginning. And finally, in 2009, the W3C released this SKOS standard, and yeah, just take a look on it. So you have a concept, you have preferred labels, you have alternative labels, synonyms, you have hidden labels, maybe wrong labels you should not use, but still they will be found in documents. You have definitions, and then you can link to others, other concepts. You can say, okay, this one has an error, and that one again has a preferred label, and so on. And it could also have a broader or a non-hierarchical relationship, and so on. So that's just a simple snippet of this knowledge graph. And from that on, and just remember the picture, the very first picture I showed you, that's the first step, of course, only to create a knowledge graph. But it's important to have something in place which can be managed easily. You have to start with something, and here I think SKOS is a great starting point. And SKOS can be visualized, of course. That's one example. Let's take a look on that. That's the PoolParty visual mapper. Just put it on top of a SPARQL endpoint, and of course you can extend the range of properties, but here it's only the SKOS properties. And here you can click around, you get an impression of nodes which are connected to certain concepts. And the connectivity is represented by the size of the circles, and you see the broaders, you see the narrows, you see the relateds, and so on. And for instance, here this browser is integrated with the search. So if I click here, I will get a search result, and of course also the query expansion is used in the background, so all the alternative and maybe also hidden labels you can configure that are being found. So for instance, PPT, which is abbreviation for PoolParty, the thesaurus server. So that's just one example, and that's pretty straightforward to build such visualizations out of SKOS. They can be understood by a lot of people, by non-technicians most of all, maybe by physicists or by lawyers and so on. And then, of course, you can also simply create a front end like that on top of your thesauri, like the school's online thesaurus. So here you can type in a search phrase, and in that case, for instance, I was searching for technology and applied studies, which is abbreviated with TAS, and then you get all the alternative labels. Here's the URI, narrow concepts, maybe a picture which was derived from a link to DBpedia, and so on. So of course this can be adapted and can be even be more user-friendly, not so technical as it is here maybe. So that's just a second example I wanted to show you. And most of all, SKOS is a standard, and if you start creating your knowledge graphs with SKOS, you can either reuse existing ones or you can link with them. You can start to map your taxonomies to those ones. I'd like to pick out one here. Is interesting. Wand, a US-based company which has been offering taxonomies for years and years. Just recently also decided to embrace SKOS. I'm very happy about this fact, and I think that's key to distribute knowledge, to use standards which can be simply embedded into other applications. And one taxonomies can be obtained for several topics like procurement, like recruiting, like information security, and so on. And now with a SKOS standard in place, more and more applications can consume them with very, very little effort. So another example for that is Wolters Kluwer, a very large publisher, decided to create knowledge graphs on top of SKOS and to publish them even as linked open data. And just recently, the German labor law, thesaurus, was published, and it was already linked with those 3 other thesauri, which are used to categorize and annotate documents from different repositories, like the Eurolex or eCompis. So what can Wolters Kluwer do with this strategy? They all of a sudden have opened the door to several other databases to create mashups between its own content and their content. And with the linking to DBpedia, they even open the door to a lot of facts which are out there. So here on the left side, actually, just imagine there's a lot of content provided by Wolters Kluwer to lawyers, for instance. And now they can make mashups between their own content and the content from Eurolex, for instance, and say, okay, there is some interesting documents for you, but there is additional one you could obtain from the European Union. So that's a service. That's an additional service on top of content provided by the publisher himself. So I think that's not the far future, that's the near future. And Wolters Kluwer is doing a great job here. Let's take a look on their thesaurus. So that's a standard front end. Of course, it's more for the integration into applications. It's not only for human beings. It's in German, so let's type in something like consultant, which is Beratung in German. And again, what you can see here is the alternative label. Beratung is consulting. There are broader concepts, and down here you see the links, for instance, to DBpedia, and to thesaurus and so on. So that's the whole idea. You can open up your knowledge and get linked to other repositories. So let's take a view on SKOS as being an intersection of 3 disciplines and their paradigms. So on the left-hand side, you see the librarians and the taxonomies. They've created for many, many years something similar, and they're very close to the idea of SKOS. On the other hand side, you have the data engineers and people coming from the artificial intelligence community. They've been talking about schemas and ontologies, and of course to them SKOS always looked to be a bit too simplistic. Can we work with that? That was the main question, I believe. And then you have the computational linguists and the information managers. They're about information retrieval, and they, I think, now finally also started to embrace SKOS for text mining, for entity extraction, and so on and so forth. And I will also show how we can, let's say, transform the tools they used to have in place for years and years to make sure that all of those 3, who are all gatekeepers to certain kind of information, how to bring those all to this SKOS idea. So how far away are we from the transformation from their typical method towards a SKOS-oriented approach? Those persons are gatekeepers to relational databases. Those are to the document repositories. And those ones are mainly the metadata managers, those who know how to create taxonomies. And those 3 information have to be linked to each other. We should consider them to be one large knowledge graph. We want to make queries over it. That's the main question. But first we have to explain to those three stakeholder groups, to those three gatekeepers, why SKOS is an interesting option for them. So first, tree of categories and terms. That's the basic idea of librarians and taxonomies. Of course, it's much more, but just let's start with that. And now we're going to tell them, okay, you could transform that into SKOS-based graphs of concepts. To the information retrieval specialists, to the information managers who would like to annotate and categorize documents, you could say, okay, let's do that, but we could also transform your documents into SKOS graphs. We could make graphs out of your documents and link them with other graphs, like the ones which are created by your colleagues from the taxonomy department. And then last but not least, I think that's the hardest nut which has to be cracked, are the ontology engineers, the database guys. They just have been working with relational databases for many, many years. Why should they now use graphs instead of that? And I'm not saying that it's going to be removed, all these oracles in this world, but we should think about virtualizing this kind of information and connect this data as it would be a graph with the other information types. And therefore, again, SKOS can be the starting point, and they can be enriched, those first, let's say, simple graphs described via SKOS, with all the schema information and restrictions and rules by using ontologies. And I will show you how that could work. And when all those three information types are nicely linked to each other, then we gonna provide interlinked views on all kind of information in an enterprise, in a large and distributed organization. Okay, let's take a deeper look on that. How can we convince or at least start a discussion with librarians to use SKOS? Also, I have to say it's not that hard anymore as it was like 3 years ago or 5 years ago even. So what's the most important advantage? You can access SKOS via URIs and HTTP. It's accessible. If you have a large terminology or taxonomy in your company and you provide it as SKOS, it can be used as a service. Taxonomies as a service, thesauri as a service. It's based on standards, and I think before I already explained that you will save a lot of costs because you can reuse other taxonomies, and they are machine readable. There are applications around to make use of that standard. And you can even create more complex structures. You can create polyhierarchies. In many cases, traditional term management systems were not able to create polyhierarchies or non-hierarchical relations, or even mappings to others. And also the clear distinction between the concept itself and its labels is very important. Let's take a look on that. I can click on it, and I will receive an answer by this HTTP call. And here it is. It could be visualized, however, with a picture. We've seen some examples now. That's Tim Berners-Lee with all his alternative labels, hidden labels, like Timble, broader concepts, related concepts. You get a lot of information around that. It's not only a couple of synonyms. It's typed. It's the religion of Tim Berners-Lee. You can look up and things. And of course, if you were in software agent now, you would rather receive the RDF version of it. So any concept on the semantic web is also available as an RDF graph. So it's very simple to access information in a SKOS taxonomy. So what about information retrieval? Why should we use SKOS to annotate documents? As I've said before, it's not an annotation, it's more transformation. So for instance, a biography of Tim Berners-Lee being annotate it with a SKOS graph about this certain specific domain, which is also linked to a lot of other sources and so on, can provide systems which can answer such questions. So this business guy here, he would like to know, okay, which biographies, or show me all the biographies of computer scientists. Maybe he's working for a recruiting agency. He's working as a computer scientist for organizations located near Boston. With a simple annotation of this document, you were not able to answer that question. That's the basic idea of why using knowledge graphs to link them with your document repositories. Although I don't think that Tim Berners-Lee would be able, no recruiting agency probably would be successful with asking Tim Berners-Lee to work for another company. Okay, and last but not least, what about the database guys? I think the main argument here constantly was discussing with them is typically when it comes to data integration. If you have different formats, different silos, of course data can be integrated, but it's done on an implicit conceptual model. It's somehow part of the application layer, the whole integration effort. And if you do that with a clear distinction between the data level and the application on top of the explicit conceptual model, so the conceptual model is somehow outside of the application, then the reuse of your conceptual models will help you to save costs, which means you can use those conceptual models which help you to integrate data from different sources again and again. And all the applications you are creating are based on standards like SPARQL, and that also helps you to reuse code. And if you add another source here, you map this information to your explicit conceptual model. And it's also important to see, and that's an organizational issue, that software engineering and data engineering now are located at different places. And I think that's important because the world hasn't become simpler in recent years. And there are domain specialists, there are data engineers, there are software engineers. And if you have an architecture which nicely splits those components apart, then they scale up much better. And especially in distributed worlds and architectures, such an approach is much better, I believe. But those guys usually say, with SKOS, we will not like to start. It's too simple. We cannot use it for data integration. And here, I'd like to present to you what PoolParty 4.2 is now offering. You can introduce ontologies and apply them to your SKOS thesauri. So for instance, here on the left-hand side, you see typical SKOS hierarchy. It's about the social semantic web. It's a domain-specific thesaurus, persons, places, standards, products, everything what's going on in this industry is here nicely linked to each other. And the concept scheme about persons obviously always contains persons. So you can apply a custom class here. You could use schema.org, you could use FOV, you could use org, which is an ontology by W3C. And you can then apply this custom class. And from that on, the whole hierarchy recursively will be typed, all the concept as being schema.org persons, for instance. And from that on, Tim Berners-Lee, for instance, is a person. You can see that down here. And it is possible now to attach several new information to this concept. For instance, following the FOV ontology, you can add a depiction, a focus, for instance, what is Tim Berners-Lee interested in. And this dramatically enhances the whole graph management, of course, because this schema logics also takes care that that there is no mistakes made. On the other hand side, we believe very strongly in start small with SKOS and let it grow. Just remember the picture I showed you at the beginning. And that's more a practical problem, because this kind of thesauri, that's feasible. To start with the ontology and then populate the ontology is a really cumbersome problem for many, many organizations. So we just think we should do it the other way around. So let's go to topic number 3, linked database information architecture. I mean, that's I think a clear, simple picture. You have different data silos, different types like documents and relational databases. You annotate them. Those annotations are together stored with the legacy data, which is more or less transformed into RDF or virtually transformed into RDF, depending on your approach. So those annotations, together with the domain-specific knowledge models, which are probably more the SKOS ones, will be stored once again together with your enterprise knowledge models. Here probably also introduce ontologies and schemas like the ones I just mentioned before, like FOV, ORG, or your own ones, your own custom schemas. And all of them are stored in a linked data warehouse. I think at the moment the federated approach is not feasible because of performance issues, but the linked data warehouse approach has tremendously was maturing enough that now it can be used for really large amounts of data. Thinking of, for instance, Virtuoso or Aulim, they can handle billions of triples now, and that's something very interesting for large enterprises. And having said that, PoolParty Semantic Integrate is exactly such an application on top of such large-scale linked data warehouses. So you add data from the web, for instance, DPP, the freebase geonames. You put in your structured information, your unstructured content, together with your knowledge graphs, and with the SPARQL endpoint, you can create applications like for business intelligence, 360-degree views, semantic search, of course, data visualization, and so on and so forth. And which problem do we solve with that? Our business guy is constantly looking for relevant information to answer specific questions, and it's all put together more or less manually. And that's very time-consuming. And we believe if there are thousands of such business guys in a company, it's worth organizing information on a central place and not at all of those places. At the moment, information management is done at every desktop, more or less. And that's not the right solution. It's better to use taxonomies for information integration. Of course, taxonomies have to be maintained. That's clear. That's a matter of fact that it's something which triggers some additional costs. But we also have to talk about the potential savings on the other side, which happens here. Document retrieval and search is still, as I've said before, in its very early stage. If transformed to a knowledge graph, we can ask more complex queries together in combination with your relational databases. And I will show you a couple of examples. For instance, there's a guy, he wants to explore medical research trends in relation to regional prosperity. Prosperity can be measured, for instance, by the Human Development Index, which is released every year by the United Nations. And you can translate this question much easier, I would say, into SPARQL than into other query languages, because that's more, I would say, close to the natural language. Of course, there's a data engineer sitting here But it's it's built around explicit semantics. And let's take a look on this application. So it's built on top of the semantic integrator. Under the hood, there is a virtuoso, and it's a SPARQL query. You can see here the result of a SPARQL query. There's nothing in between. Also the visualization. Of course, there's a mapping to this corresponding pie chart, but that's something which can be adapted easily. Also, if you want to introduce new categories. Like, let's say here we have 3 of them. I now want to see, okay, what's about nervous system diseases in, I would say, rather poor countries, like, as you can see, low human development index. On the other side, compared to rather the rich ones. So what's the big difference here? Okay, here in the Western countries, as Austria, I would say, we have more those problems, and research is done on things like Parkinson or dementia. People in such countries, they would not have such problems. They have complete others. And you can see that instantly, and of course, also the documents adapt to this to these queries. So actually, you're asking a very complex question here. And again, you get not only documents, but also results like that. Yeah, and then, of course, you can click here and you will be redirected to PubMed. So how is it working? You have a knowledge graph called Mesh. You have another knowledge graph called GeoNames and another one called DBpedia. Those 3 are all put together into a graph database in combination with the documents which were transformed into graphs. And then you do such SPARQL queries. And yeah, it's really agile, and that's the great thing. You can add additional graphs and ask even more complex queries, or do other categorizations and filters and things like that. So what happened here? Actually, usually you would do the integration on top of databases, and here we actually transformed the knowledge the databases into knowledge graphs, and did the mapping with taxonomies and thesauri. And I think that that's also something you should keep in mind. That taxonomies are not only for semantic search like query expansion and autocomplete. That's the typical application type, or annotating documents. They can really be used to map different databases and to data integration and information integration. Yeah, now I'd like to come to the final topic of this webinar. I hope you enjoyed it so far. And of course, I'm now proudly presenting PoolParty 4.2. We've been working for a while on this release, and it's finally out now. And maybe you know this guy. The answer to taxonomy, ontology management, and everything is PoolParty 42 or 4.2. However you want to say it. Yeah, so that's, of course, just a little joke, but let's start. For those persons in the audience who have not so much knowledge about PoolParty, so we were asking about who has been using PoolParty or has known PoolParty before. About 50% of the registrations, which were about 170 now, said yes, and 50% said no. So please excuse me to those who know already what it is, more or less. A few words. It's user-friendly. You can create and maintain knowledge graphs. It's standards-based. Everything based on W3 standards. We natively build on graph database, no mapping in between. We are embedded in the ecosystem and make a lot of usage of linked open data and linked data sources. It's best of breed. You can combine text mining software and taxonomy and ontology management. It's enterprise ready. You can install it, of course, on premises. There's also a cloud version. It's secure. it's enterprise secure. We have large customers who have more or less made a lot of audition on that question, of course, and security is a big issue here. So it's enterprise ready. Most often semantic web software was said to be, it's academic stuff and it's not enterprise ready. That's not true with PoolParty, at least. It's simple to install and it's integrable. That's you can integrate it very easily. There's an API. There are connectors for SharePoint, for other content management systems, for Confluence, and so on. It's all browser-based. That's very important, I believe. You have drag and drop, autocomplete, and all those things. So knowledge graph management isn't that cumbersome anymore. So here, for instance, you see the tree. You see here the SKOS view. There are, of course, all the other views on a concept. There's the drag and drop feature, so here you can create a relation by dragging and dropping a concept. You can import and create your own ontologies. So we have a library of most often used ontologies like FOV or org. You can create your own ones. And here we also were focusing a lot on people who are not from the artificial intelligence community only. It supports or enables people who are not fully aware of what an ontology is to create such new properties. For instance, here you see a pretty complex one already, new relation between a product and a standard, and the product uses a standard and the standard is used by a product, and here you can of course create your own URIs if you want. And then you created already a pretty complex ontology. You can apply those on a SKOS model, so you can classify them. From that on, for instance, here, places, you apply from the geo ontology the class spatial thing, and from that on, all the, for instance, countries or places are a spatial thing, and of course inherit all the properties or are allowed to have all those properties you can see here. And here we make a clear distinction between, again, relations between two entities and attributes. Like with SKOS here, we also have in the SKOS tab here on the left side, broader, narrower, related, and on the right side we have the labels and the definitions, and that's very similar to all the other ontologies. So that's something which can easily be learned. There's relations and there are attributes. You can apply ontologies on a SKOS model, and as I've said, for instance, here, the PoolParty thesaurus server is not a product yet. It's not defined as such, so there are no properties available. As soon as you apply this custom class product, it will get all the information which you have put in your schema ontology, and here you see now it has a version, it can be used by a project or by a company, and it can use standards or other components, for instance. And now the rule engine of PoolParty takes care of that only those entities will be connected which follow the ontology, and that's something, of course, that's clear. I mean, SKOS didn't offer that. That was one of the problems. And on the other hand side, without the restrictions, first you can create a first version of a graph and then put the additional, more specific information on top of it if you want. For certain applications like entity extractions and so on, it's probably not even necessary to do that. Yeah, you can make use of linked open data. So here, for instance, Brussels was attached or mapped to the corresponding DBpedia concept. That's done automatically by PoolParty. And then you can retrieve information like longitude, latitude, different types. So you, for instance, now know that Brussels is a schema.org place. And after you have done that, you can ask tricky questions like, who is the most influential people in the world? Who of them are Princeton University alumni, for instance? And then you get those two. And that's of course, something which is available, such kind of information. You just attach it to your concept you created first. In that case, it's Carl Kahn. And Carl Kahn now is attached to Princeton University alumni, and that's why we can answer such questions. So the reuse of ontologies from LOD sources is, I think, one of the key aspects here. As soon as we know that Brussels is a schema.org place, we can attach information like contained in Belgium, or it has a map and things like that. And of course, you can also link between several thesauri and taxonomies. So for instance, here we have a project linking dialog. So the places in my social semantic web thesaurus are here linked to a geographic thesaurus. And from there, probably other facts can be used for my information machine. You can make use of text corpus analysis, which means you can analyze thousands of documents, which help you to detect new candidate terms. So you can see here new candidate terms, and on the other hand side, you can also find out which of the entities in your knowledge graph are frequently used in the document corpus to maybe refocus a little bit on your thesaurus work. So that's one of the analyzed pages here, and that also can be used, of course, for document annotation outside of the taxonomy management itself. Yeah, and that's exactly what you can see here. So you create thesauri, deploy that as an extraction service, and transform your documents into RDF graphs together with your knowledge graphs. You store them in your linked data warehouse and ask tricky questions about your repositories. You can integrate that by means of the PoolParty power tagging layer into SharePoint, into Confluence, into Drupal, into WordPress, and others. And of course, you can use PoolParty also for, I would say, simple semantic search. So that's also a little online demo. I want to give you one of the highlights here is the smart suggest feature, for instance. So if you type in something like glucose or so, or diabetes maybe, then you get a categorized autocomplete, and by switching on the smart suggest, you even get related stuff. For instance, glucose intolerance. You might have forgotten that, but you know something which was related, and then you find the right search queries. That's one of the ways how to use a knowledge graph in a search interface, and of course the facets and content recommendations, similar documents and stuff like that is improved by using knowledge graphs. Yeah, and then I think I finally come nearly to an end. That's the, let's say, the master class of linked data applications, I would say. That's the semantic integrator, as we call it. It's about data integration. Another example here, for instance, I would like to know how is solar thermal at the moment used in, let's say, English-speaking countries and things like that. So here we use the Yago classification, the Yago knowledge graph. We use DBpedia, we use GeoNames, we used the Regal thesaurus, which is about renewable energy. And then again, you get, of course, on the one hand side, a fact box, you could call it, and on the other side, a document list. And that's, I believe, how information machines or engines will look like in the very near future. So that's the final message. Start, SKOS, grow big. Let your knowledge grow. I hope I was able to deliver the message. SKOS is a starting point. It's not the end. It's not the final version of your knowledge graph, but you have to start somewhere, and you can teach a lot of people about SKOS. It's simple enough, and you can start to link your SKOS graphs with other information. So long, and thanks for all the links. That would be my final message, I think. 2 announcements. There is a Semantic SharePoint webinar in about 1 month. And there is the 10th International Conference on Semantic Systems in September in Leipzig. Very happy to work here with the DBpedia folks from University of Leipzig and the whole international DBpedia community. I believe DBpedia is one of the most promising projects in that field, and there are a lot of opportunities here, and we have great keynote speakers from largest systems integrator Cognizant, from BBC. We learn about the linked data platform of BBC, very exciting project. We have Ori Erling from OpenLink Software. He will talk about Virtuoso and the latest developments here. And we have Phil Archer from W3C as one of the keynoters, and I believe a lot of other very interesting talks. It's still possible to submit talks, so if you have something on your mind, please go to semantics.cc. Thanks a lot for your attention. The slides will be, the link to the slide will be sent out in a follow-up email. Also, the webinar was recorded, so there will be a screencast out there. And now I think maybe there are a couple of questions still open. It's now about 60 minutes. Whoever wants to stay with us, I would be happy to talk to you in person if there are any questions. So yeah, thanks a lot for all of you for your interest, and hope to talk to you soon. Bye-bye. Okay, so now I would say more the unofficial part will start. There are a couple